In this lesson, we're going to look at complex numbers. They're sometimes called imaginary numbers, but they are useful. A complex number, we're going to define I squared equal to -1, where I is going to equal the square root of -1. Until now, we haven't been able to take the square root of a negative because there's no real solution for the square root of a negative. But we're going to define I squared equal to -1. I cannot be a real number because if I square a negative, I would get a positive. If I square a positive, I'm going to get a positive. So I is not a real number. So our imaginary unit, I is equal to the square root of -1. And if I square I, I'll get -1. A complex number is a plus bi, where a and b are real numbers. If a is equal to 0, you don't have the a part, so you'll just have bi, and that's going to be called pure imaginary. For the powers of I, it goes in a circle. So I is equal to the square root of -1. If I square it, I'll get -1. And if I multiply I squared with I, that's I cubed, and that's going to be -1 times I, which would give you -I. And then if I multiply this by another I, I'll get I to the 4th, which equals 1, and then it repeats itself. So this would be I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th, and it would keep repeating itself. So if you have something in the future like I to the 17th, you could divide by 4, and 4 goes into 17 4 times with a remainder of 1. So that would tell you where you are on this circle. So if you have a remainder of 1, then the answer is I. So you could figure out ones in the future without having to count on the circle. Let's practice simplifying some stuff with I. For this first example, this is 5 times I to the 3rd. And I think I'm going to zoom in on these. I can write this as 5 times I squared times I. That's still I to the 3rd. And I squared is defined as -1. So this will be -5i for my final answer. For the next one, I have 4i squared. So this is 4, and anytime you see I squared, you're going to replace that with -1. So that's going to give you -4. And my next one is I to the 6th. Let me zoom out just a smidge. I can write that as I squared times I squared times I squared. Or you could go around on your circle or look at the remainder. This is going to be -1 times -1 times -1. And so that gives you -1. Or if you just want to look at 4 goes into 6, and that'll have a remainder of 2. You can look up here at your chart, and if you have a remainder of 2, the answer is -1. But that one's not too far in the future that you could just write it in terms of I squared. On the next one's radicals, I have the square root of -16. I can write this as the square root of 16 times -1. Square root of 16 is 4, and the square root of the -1 is I. So whenever you have a negative under the square root, you can pull it right on out, and that's going to give you an I. On the next one, I have a negative on the outside. Square root of a negative is going to give you an I, and square root of the 36 gives you 6. On the next one, Square root of negative 4 over 9. Square root of the negative 4 is 2i. And square root of 9 gives you 3. And that's your final answer on that one. On the next group, these are nice because they're super easy. This is a negative, so I'm just going to distribute this. And a negative negative gives me a plus there. And you add real parts together and you add imaginary parts together. So it's treated just like x would be a variable if you were working with polynomials, but this is a 9. So I have 6 and a negative 4. That gives me a real part of 2. And 3i plus 1i gives me 4i. So that'll be my imaginary part for my complex number. On the next one, I can just drop my parentheses since there's a plus. Combine your real parts. 2 plus 7 gives you 9. 5i minus 2i gives you 3i. And on the next one, distribute the negative. That's going to be plus 9 and plus 3i. Combine your real parts and you'll get 13. Combine your imaginary parts, that gives you 11i. Now we're going to look at multiplying. So you multiply just like you would if you had a monomial times a binomial. So just distribute. So I times 2i gives you 2i squared plus 3i. And we just went over that whenever you see I squared, you're going to replace that with negative 1. So that's going to be 2 times negative 1 plus 3i. And so your final answer is negative 2 plus 3i. On the next one, you're just multiplying those together. That's negative 10i squared. We're going to replace any I squareds with negative 1. Negative 10 times negative 1 gives you positive 10. And the next one I'm just going to use FOIL on. My first gives me 8. Outside gives me minus 4i. Inside gives me 12i. And last gives me minus 6i squared. And whenever I see the I squareds, I'm going to replace that with negative 1. So this negative 6 times I squared is going to be negative 6 times negative 1, which gives me a plus 6. So I'm just going to circle that and write plus 6 underneath it. Now let's combine our like terms. 8 plus 6 is 14. Negative 4i plus 12i will give you 8i. We're going to be solving now some problems that may or may not have I. For the first one, I want to get x by itself, so I'm going to subtract 42 from both sides. So that will give me 5x squared equals negative 45. I'm going to divide both sides by 5. So x squared equals negative 9. And then when I take the square root of both sides, I get plus or minus the square root of negative 9. And square root of the negative is I, and square root of the 9 is 3. So that'll be 3i. On the next one, number 2, divide both sides by negative 2. Then take the square root. You'll get plus or minus the square root of negative 16 when you square root both sides. And so x will equal plus or minus square root of the 16 is 4, and square root of the negative is I. On number 3, subtract 6 from both sides. And then I need to multiply both sides by 3. So that gives me negative 24 on this side. Take the square root. So x will equal plus or minus the square root of negative 24. And I'm going to write that in terms of its perfect square that goes into it. So 4 goes into 24. So I'll write that as 4 times 6. And there's no other perfect square that will go into 6. So 4 is my largest one. And then I'm going to pull out square root of the negative 4. So square root of the 4 is 2. Square root of the negative is I. And then you're left with the 6 inside. On number 4, I'm going to subtract 5 from both sides. So that gives me negative 40 on the right. And now I'm going to divide through by 4. And then take the square root of both sides. And then to solve for x, I'm going to add 1 to both sides. So this will be 1 plus or minus. There's no perfect squares that go into 10. However, I can take out the negative, which will give me I square root of 10. On number 5, I'm going to subtract 1 from both sides. Then divide by 3. And now I'm going to take the square root. Square root of 9 is just 3. That doesn't have a negative on it. So this will just be 3. And then move the 2 to the other side, so I'll subtract 2. So x equals negative 2 plus or minus 3. And I can simplify this because I can combine those together. Negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. On the next one, number 6, I'm going to subtract 6 from both sides. Then multiply by 2. And then I'm going to take the square root of both sides. So that will give me plus or minus the square root of 50. And notice there's no negative on it, so I won't have an I. But there is a perfect square that goes into 50. 25 goes into that. To get x by itself, I'm going to add 4. And then I can simplify my radical. The square root of 25 is 5. The perfect square gets to come out, and the 2 is left inside. Last example. I'm going to go ahead and add 6 to both sides, so this now becomes a 4. And to get the x squared by itself, I'm going to multiply both sides by 36. 4 times 36 will give me 144. And that's a nice perfect square, so this will be plus or minus 12.